11.1 is finding measures of central tendency and dispersion. Okay. So you have done this before, sort of, not everything that we talked about you've done, but what is mean? Let's recall back
It's all the
to
averages.
elementary school. What is
Add
it?
up all the things and then.
Yeah, it's the average, right? It's the
Yeah,
average. So my mean is my average. You add up everything and divide by the total number there is, correct?
Mhm.
What's my median?
The middle value.
The middle value, so you have to line them up in numeric order, and you just keep going, and if it comes down to being 2 in the middle, what do you do with those two?
Divide them.
Add them together, divide them by 2, find the average of it, okay? So it's like the middle, okay? What is my mode?
Number that occurs the most.
Yep, occurs most, okay?
You did math for that.
And then the next thing that you're gonna hear today is the measure of dispersion, okay, the measure of dispersion. It's how far the data is spread out. So an example of the measure of dispersion, the easiest one that we can talk about is range.
So, what did you say?
Because there are different types of measures of dispersion, so it's an overarching term for several different things. Does that make sense?
Yeah.
Okay, and we're gonna look at one of those today called standard deviation. Okay. Standard deviation is denoted with this. Do you see this right here? When you
Yeah.
see that like little cursive O, it looks like, it means you're looking for standard deviation, okay? That is read as sigma, so it's saying sigma, okay? Sigma is standard deviation. Standard deviation has a formula, and it's taking your first value, subtracting it by, what do you think this X bar means? Anybody have a clue what X bar means?
Oh no, it's the one minus the thing.
Is it repeated?
Mm-mm. X bar goes with this right here. It is your mean.
No.
So you are taking the first term minus your mean squared, plus your second term minus your mean squared, plus your third term minus your mean squared, and so on and so forth for however many terms you have. That means you have a lot of work to do, but not difficult work. And then you divide that whole thing by the number of terms you have. And then you take the square root, and that's how you get your standard deviation. It's just a formula, okay? So, actually, let's do this. I'll go grab books for you guys, and we're gonna turn to some pages and do some data work on. Okay. Page 744. Turn to page 744. Because I didn't want to write all these charts out, so we're just going to do it off the book. And get out a calculator because you'll need it most likely. Page 744. Let's start with example 1, and I know it's worked out there, but I want to see you do it as well. It says the data sets at the right give the waiting times in minutes of several people at 2 veterinarian offices. Find the mean, median, and mode of each set of data. Let's only do office A and find the mean, median, and mode, okay? So how do you find mean again? Yep, add them up and divide. Bless you. And so when we're writing this, I'm going to say, I'm going to write mean like this from now on, because you got to get used to it. So what's the mean of all that data? When you add it up, how many do you divide by?
9.
9. So you should get, the mean is 22. Okay, when I add all those numbers and divide by 9. Now to find median, you told me that's the middle, so I've got to arrange that data in order. It's already arranged in order for me, yes?
Yes.
So 14, 32, 17, and 30, 24, and 20, 18, and 30. Am I doing that? No, I'm being crazy. 14, 32, 17, 30, 18, 24, 19, 24. So 20 is the middle number, yes?
Yes.
And then the mode is what happens most frequently. So what number takes place most frequently should be 24, correct?
Mm-hmm.
Okay. So we're gonna do this as the first part of our homework tonight, finding mean, median, and modes. Cool? What would be the range of this data set?
32 minus 14.
Good, 32 minus 14, so my range would be 18, okay, if I were to find the range. Okay, now, look at, that standard deviation, example 3. What is the standard deviation of the waiting times in each set of data, okay, for example 1? So what you have to do is this. We're gonna take office A, right, because we're only gonna focus on A. And all the numbers for A were 14, right, 17, 18, 19, 20, 24, 24, 30, and 32, yes?
How'd you get the numbers?
Okay, I went back to the data set that they gave us.
Oh, so we're using, okay.
Yeah, we're gonna use office A, okay? And I want the standard deviation. The standard deviation is x1 minus my mean. Do I have a mean already for this set of data?
Yes.
Yes, so I literally have to set up an equation that looks like this. And I want to see you write it out. And I know that's annoying and a pain, but until we get used to it, I wanna see it written out, okay?
So we have to go all the way to 32.
Correct.
Are you serious?
You have to do it for
All the way to 32.
every piece of data, yes. Now do you see why people don't like doing standard deviation?
Yeah.
Okay, and it's all over 9, right? Because I should have 9 terms, correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you take the square root of whatever that is. Do you get what I'm saying here? Okay, so, what's 14 minus 22? Negative 8, right?
Yeah.
So I have negative 8 squared plus 17 minus 22, which is negative 5 squared, plus 18 minus 22, which is negative 4 squared. 19 would be negative 3 squared, right?
Yeah.
20 would be negative 2 squared. 24 would be 2 squared, correct?
Mm-hmm.
2 squared, 12 squared, and, oh no, not
8
12,
squared.
8 squared. And 10 squared, right? All over 9 divided, and then the square root of that, yes? Okay, so negative 8 squared, and remember, if you do this in your calculator without parentheses,
Yeah,
it's gonna give you negative 64. So you just have to be smart enough to. So you have 64 plus 25 plus 16 plus 9 plus 4 plus 4 plus 4 plus 64 plus 100, yes?
Yeah.
And then divide that by 9, and then take the square root of that answer. And you should get something like 5.7 when you round it, to round it to the 1 decimal.
I don't think it's gonna be hard. I think it's just gonna be
Yeah, it's not hard, it just takes time, okay? Just takes time. And so that is your standard deviation. Now, there's one other term we need to talk about, and that would be this word, and you tell me if you know what this means. Do you know what an outlier is?
Yes.
What?
It's like a number that, well, kind of, it's a number that does not fit the data.
Beautiful, yes, it's a number that is either way too high or way too low for the data. It doesn't fit the rest of the data, okay? So an outlier kind of skews your terms a little bit because it doesn't really fit that data. So be aware of outliers or be able to recognize them when they ask for them. Cool? And a lot of times we'll take an outlier out of the equation, out of the mix, and find the real set of data for that. That's what this whole section's about. Okay? So I'm gonna give you some homework because I think you can handle this.